In today's lesson, I want to focus on ratios, rates, and conversions. The objective is to find ratios and rates and to convert unit rates. The standard is to use units as a way to understand problems and to guide the solution of multi-step problems, and choose and interpret units consistently in formulas. So let's get started with this. Need to know some key vocabulary. A ratio is just a comparison of two numbers by division. A rate is a comparison of quantities measured in different units. And the unit rate is just a rate with a denominator of 1. Let's get started with some real problems. I love this lesson because I get asked a lot, when am I ever going to use this in the real world? And I use this every single time I go to the grocery store. Anytime I get on Amazon and I'm comparing prices. This is a mathematical concept that you will use over and over and over again if you're a conscientious spender. And trust me, once you get a job and you're making the money, you're not going to want to just blow it on anything. You're going to be a little bit more conscientious and shop around for better prices probably than you do as of right now. So let's look at some real world problems here. It says at Maurice's there are 2 shirts for $25. At Route 21 I can get 4 shirts for $45. And at American Eagle it's $30 for 3 shirts. First we want to write each price as a ratio. I'm going to stop right there and I'm going to go ahead and do that. Write each price as a ratio. So price per shirt, so it's 25 for 2. It's 45, once again, price per, this line, when I think of this line, I always think of per. Price per shirt. And then American Eagle, it is $30 for 3 shirts, so price per shirt. Okay, so looking at this, now it says to then write the ratio as a unit rate to compare. So if we go back, what is a unit rate? It's a rate with a denominator of 1. So we want it to be equal to something over 1, something over 1. Basically what we're wanting to know is what is the price of 1 shirt. So the way that I can do this is I can just divide. 25 divided by 2 is $12.50. So it's $12.50 for 1 shirt at Maurice's. If I divide 45 by 4, I get $11.25. So it is $11.25 for 1 shirt from Route 21. And then the last one, I don't even really need to think about that. It's $10 for 1 shirt. So then it asks, which store offers the best deal? Well, of course, the shirt that offers the best deal is American Eagle. At American Eagle, I can get 1 shirt for $10. That's $1.25 cheaper than Route 21, and it's $2.50 cheaper than a shirt from Maurice's. So the best deal is at American Eagle. Let's assume that Route 21 is running a sale, and it says they are now offering their 4 shirts for $42. Does my solution change? Let's look and see. What is 42 divided by 4? It would be $10.50, I believe, for 1 shirt. So did my solution change? Nope. The solution did not change. The price is still cheaper to get them at American Eagle. I mean, it changed the price for the Route 21 shirts. You know, they're 75 cents cheaper now, but my shirts from American Eagle are still 50 cents cheaper than the ones from Route 21. Okay, if I'm converting from one unit to another, this is another type of problem where rates, ratios, and conversions come into play. We know that we can compare feet and inches. 1 foot is the same as 12 inches. 1,000 grams is equal to 1 kilogram. We know there are 60 minutes in 1 hour. So we can write this the other way too. We can say, okay, 12 inches over 1 foot. Or we can say 1 kilogram over 1,000 grams. Or we can say 60 minutes in 1 hour. It all depends on the way the problem is set up, how we are going to use this conversion factor. Which way do we want it? Do we want feet over inches or do we want inches over feet? So let's think about this. We've got 330 minutes is to how many hours? So we're looking for the number of hours. Okay, well we know how many minutes are there in an hour? There is 60 minutes in 1 hour. Well, I don't know why I put that equal sign there. I want to be able to cancel out my minutes because I'm wanting to go from minutes to hour. So we know that if I have the same thing in the numerator and the denominator, I've told you before, if you've got 3 over 3, that is 1. 5 over 5, that is 1. If I have some big long thing, we talked about this when we were simplifying equations, if I have g plus h over g plus h, that equals 1. Well, the same's true in conversion factors. If I end up with minutes over minutes, those cancel each other out. So that's what we're wanting to happen when I'm converting from minutes to hours. I want to be able to cancel out the minutes. So I know right now that I've got 330 minutes, and I want to know how many hours is that. So I'm going to put my hours on top, so 1 hour is to 60 minutes. And I'm going to multiply it. So 330 minutes times 1 hour divided by 60 minutes. Look what happens. I have minutes on top, minutes on bottom. They cancel out, and I'm just left with the unit of hours. Well, 330 over 60. I know right off the bat my zeros are going to cancel. So now I'm just asking myself, what is 33 divided by 60? And 33 divided by 60 is 5.5. So it would be 5.5 hours. So 330 minutes is equivalent to 5.5 hours. Okay, let's try another one. I didn't allow myself very much room, did I? Okay. I'm wanting to convert kilograms into grams. So I've got 15 kilograms, and I know that I want the kilograms to cancel out, so I'm going to have kilograms on the bottom. So let's look. 1 kilogram is to 1,000 grams. So now we can just multiply. So that would be the kilograms and kilograms cancel out. 15 times 1,000 would be 15,000 grams. So 15 kilograms is equal to 15,000 grams. And this is something that you're going to use in Mrs. Kuhn's science class. You're probably going to use it in other science classes. It doesn't really matter. When you have it, you are going to or what science class you have, you're going to have to convert units of measurement. It just comes up over and over and over again. So let's look at the next problem. We've got 5 feet and 3 inches, and we want to convert it to inches altogether. So I'm just going to kind of ignore this 3 inches because it's already converted to inches. And I'm going to think about my 5 feet. Well, how many inches are in 1 foot? And where do I want the 1 foot to go? I want the feet to cancel with feet. So 1 foot goes on the bottom. We know that there's 12 inches in a foot. So I want to times 5 times 12 is what, 60? Yep, 60. So that gives me 60 inches. Well, now I've got to go back to this 3 inches up here. So because I didn't just have 5 feet, I had 5 feet and 3 inches. So we know that 5 feet's the same as 60 inches. So plus that 3 other inches gives me a total of 63 inches. In each one of these problems, we used units for each quantity. So notice that the units for each quantity are included in the calculations to help determine the units for the answer. So let's look at some application problems where we're converting units between systems. So let's think about some architecture. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? And we want to use the fact that 1 meter is approximately 3.28 feet. So what I want to know is, first of all, how should I set it up? I've got 1,815 feet, and I'm wanting to convert it to meters. So should I put meters over feet, or should I put feet over meters? Well, if you remember, when I multiply this, I want the feet to be in the denominator because over here it's in the numerator, so I want it to cancel. So if I put the 3.28 feet in the denominator, it's going to cancel with the feet in the numerator here, leaving me with the unit of measure that I want, which is meters. So I end up with feet cancel, feet cancel. If I multiply straight across, I get 1,815 divided by 3.28, which, I can't do that math in my head, is 553 meters. I had to cheat. Okay, so it is 553 meters is the same as 1,815 feet. And I always like to look back and think, does that make sense? 1 meter is 3.28 feet. So I would expect it to be more feet. There's more feet than there are meters. So my final answer, since I converted feet to meters, I would expect it to be a smaller number because when I'm comparing these two, the meters is a smaller number. So it seems to make sense in terms of the problem. Let's try another one. I would encourage you to pause the video at this time and try this problem on your own. And then after you're done trying it, turn it back on and check and see if you did it correctly. So a building is 1,450 feet tall. How many meters tall is the building? So once again, we know that 1 meter is the same as 3.28 feet. I'm going to multiply. The feet cancel. So I'm left with 1,450 divided by 3.28, and this is meters. So my final answer would be 442 meters. Once again, I know that it should be smaller than what I started with because there are more feet than there's 3.28 feet in 1 meter. So of course it would make sense that there's 442 meters to 1,450 feet. Okay, monetary exchange rates change from day to day. On a particular day, the exchange rate for dollars to euros was about $1 is equal to 63 euros, or 0.63 euros. That's a huge difference. About how many euros could you get for $325 on that day? This is a real thing. This is very applicable. When I went to China, 6 cents in Chinese money was equal to $1 in American money. I think is how it was, or maybe it was vice versa. I can't remember. But either way, I exchanged my money when I went to China, and I felt like I was a millionaire because my money went so much further in China than it would here. So what this is wanting to know is if you have 325 US dollars, how many euros would you get? So we've got $325. And we're going to times that by dollars to euros or euros to dollars. Now let's think about this. We want the dollars to cancel out. So the dollar amount needs to go on the bottom because we're wanting to solve for euros. So 0.63 would be on top. So 325 times 0.63 gives me a total of 205 euros. If I think about that, $1 is equal to 63 cents in euro money. So, of course, it's not going to be as much. If I have $325, it's not going to be as much money in euros. So I would have $205. I shouldn't have said dollars, I meant euros. It's not the same. Okay, converting rates. You can convert miles per hour into feet per second if you want. We have to multiply by 2 conversion factors, though, because we're changing both units. So, a student ran a 50-yard dash in 5.8 seconds. So, 50 yards in 5.8 seconds. He wants to know how many miles per hour was he running. Round to the nearest tenth. So let's think about a plan here. A few things that I need to know to begin with is that 1 mile is equal to 1,760 yards. So 1 mile is the same as 1,760 yards. Now I chose to write it this way because I want, once again, my yards to cancel. So now I've got miles per second, but we don't want miles per second. We want miles per hour. So I know that I need to get rid of the second. So in order to get rid of seconds, I need to think, okay, how many seconds are there in an hour? Well, there's 60 seconds in a minute, 60 minutes in an hour. So that means there are 3,600 seconds in 1 hour. So now I can multiply. My yards cancel out, my seconds end up canceling out, and then I'm left with miles over hour, which is good because we've got miles per hour. Oops, should scoot that over. But 50 times 1 times the 3,600 divided by 5.8 times 1,060 is going to give me 180,000 miles over 10,208 hours, which simplifies to, if I divide that out, says, and it tells me to round to the nearest tenth, so we're not worried about keeping it as a fraction, as I've been telling you. It divides out to being 17.6 miles per hour. And that sums up our lesson. We covered each topic that we said we were going to at the beginning. Finding ratios and rates and converting unit rates was the goal of the lesson. And we did that by converting, figuring out the unit rate and using that to figure out the cheapest method. Then we converted minutes to hours. And then we even got real technical and we converted multiple things, yards per second into miles per hour.